Okay, well, I want to start off by reviewing a graphing quadratic function. We do have a checkpoint on this tomorrow, and then I will move on to examples from what we did today in class just to review. First of all, we have a quadratic function. We know that because we have the highest degree is 2. Therefore, it is a quadratic function that belongs to the polynomial function family. First thing I'm going to do is identify my a. It's the coefficient for an x squared, which is 1. My b is 4. And my c is 8. Okay? A is 1, b is 4, c is 8. Now, we need a few things, we need to determine a few things in order to graph this. First of all, we need to find the vertex, the y-intercepts, and the x-intercepts known as zeros. We need to find those three things in order to graph this. First thing we do is find our vertex. I find the vertex by going x equals negative b over 2a. Remember that negative b means opposite. Negative 4 over 2 times 1. X equals negative 4 divided by 2, which is negative 2. To find the y value of my vertex, remember your vertex is an ordered pair. I'm going to plug this f of negative 2 back in. F of negative 2 equals x squared plus 4x plus 8. That gives me 4 minus 8 plus 8, which comes out to 4. So my vertex, my ordered pair is negative 2, 4. My y-intercept is always your c value. So my y-intercept is equal to 8. Now I'm going to find my zeros, my x-intercepts. To find my x-intercepts, I plug 0 in for my y value. I look there for a moment and I see if I can factor that instead of equal to 0. It appears to be easy, but you cannot factor. You cannot think of two numbers that multiply to give you 8 and add to give you 4. Therefore, you have to use the quadratic formula. Negative b plus or minus b squared minus 4ac over 2a. Opposite of b, that's going to be negative 4 plus or minus 4 squared minus 4 times 1 times 8. All over 2 times 1. Negative 4 plus or minus 16 minus 32 over 2. That leads to negative 16 under the radical. Because I have a negative 16 under an even root, therefore these roots will be imaginary. They will not be real. They do have roots, but they're too imaginary, not too real. So since they're too imaginary, they will not appear on the graph. The square root of negative 16 is 4i. 4i. I look at all three numbers. I can take a 2 out. Negative 2 plus or minus 2i. So now I'm ready to graph these. Once again, you will not graph these imaginary roots because they're imaginary. But I will use my vertex and my y-intercept to produce a quality graph for this situation. So we have negative 2, 4. Okay, I have only 2 points. I have my vertex, and since this A was positive, I knew it was going to be a min. It's going to be a valley. Now, I'm going to go up from my vertex, my line of symmetry. It is 2 away here, so it'll be 2 away on the other side. And that is my graph for this quadratic function. Remember, we do have a checkpoint on this tomorrow, so review your notes. Remember, if you get to this step, and let's say there had been a negative a value, you need to factor that negative out before you proceed. But this was good. Alright, so let's talk about some things we've been doing in class so far. We've talked about standard and factor form. Standard, you know what standard is. Factored is proof of parentheses. And our learning target has been I can sketch the graphs of polynomial function by using zeros. I can sketch the graphs of polynomial function by using zeros. So we've basically been looking at this form, determining the degree, the leading coefficient, and the zeros. Alright, so let's look at this example. Number 1, we have y equals negative 2x, and I'm just coming up with these examples. They are not in your notes. This is in factored form, so the first thing I need to do is find my degree. Remember, in factored form, you count each x. 1, 2, now you got to count this twice, so it's going to be 1, 2, 3, 4, so degree 4. Your leading coefficient, the leading coefficient is negative. So that means since degree 4 and leading coefficient, it's going to be something with the arrows pointing down, the ends pointing down. Let's find the zeros. I set that equal to 0. Negative 2x equals 0, x equals 0. There's not an exponent with it besides 1, so you do not have to put a multiplicity. This will be x equals negative 3, and then x equals 1 with a multiplicity of 2. So I'm going to put dot at 0, a dot at negative 3, and a dot at 1. Remember, it's going to be the ends will be sticking downward. So at negative 3, there's no multiplicity. I'm just going to go through it. I'm going to go through 0. Now at 1, we are bumping it because it's an even multiplicity. I do not go back through it. I just bump the graph. Now let's practice our end behavior. As x goes to negative infinity, y goes to negative infinity. Period. As x goes to positive infinity, y goes to negative infinity. Just practicing that. Number 2, here's another example. Y equals x to the 5th minus 2x to the 4th minus 8x cubed. Okay? This is in standard form. Okay, it's easy to determine the degree in standard form. You just look at the highest exponent. Degree is 5. My leading coefficient is a positive 1, so I put a positive sign. Now, we need to put it in factored form so it would be easier to look at and determine a 0. So, the only thing I can do right now is GCF, so I take an x cube out. That leaves an x squared minus 2x minus 8. Now, look inside that. That looks like easy to me. So, x cubed, that's going to be x minus 4 and x plus 2. Now, I can determine my zeros. First one, x cubed equals 0. X equals 0. Multiplicity of 3. Next, x equals 4. There's not an exponent greater than 1, so you don't have to note a multiplicity or anything. Then x equals negative 2. Draw a graph. We have one at negative 2 is 0, a 0 at 0, and at 4. Remember, zeros are where they cross the x-axis, and they're also solutions to quadratic equations. Alright, now, degree 5, and it's positive. So think in your mind, it's going to be something like this, increasing from left to right. Alright, so I'm going to go negative 2. There's nothing going on at negative 2, so I'm just going to go straight through it. At 0, I break. So you see how I made like a little break right there. And then I go back through 4. And that is my graph. There's a break there at 0 because you have an odd multiplicity. Once again, practicing our end behavior. As x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. The y values. Okay, one more example. Alright, this is in standard form. So degree 4, leading coefficient is positive. We need to put it in factored form in order to graph it easily. So I can take an x squared out. That's going to be x plus 4 times x plus 4. Well, here's the reason we have multiplicity. We have the same thing up here in both parentheses, so I can rewrite that as x plus 4 squared. And it's important that you do that. So now my zeros. Set that equal to 0. You got x equals 0, multiplicity of 2. Set that equal to 0. You got x equals negative 4, multiplicity of 2. Degree 4 and the leading coefficient is positive. That means both ends are going to be sticking straight up, something like this. So, since they both have an even multiplicity, that means I'm going to bump it. I'm not going to all the way through it. I'm just going to bump it and continue on. As x goes to negative infinity, y goes to infinity. As x goes to positive infinity, y goes to positive infinity. So, remember your homework for tonight. If you are dual enrollment, Math 112, your homework came off the homework sheet numbers 14 through 19 and page 10 in your notebook numbers 13 through 15. And remember, I want you to think about the PSAT problem, number 12. Pre-AP, pre-cal, your homework is just the homework sheet, numbers 14 through 19 only. Alright, well, I will see all of you tomorrow. Hope you have had a great day.